first thing you have to do is you have to break their will. uh, All right. So last time we talked about inheritance, right? And we kind of created this this idea of we can create classes in terms of other classes, and this is more of an organizational tool that we can use to make us duplicate less code. All right, so we just kind of review here. We went through we created this idea of a coin, right? And we said, you know, coins actually have two different constructors. We have a base constructor that takes nothing as a parameter. It just kind of creates a generic coin. Okay, but we said that in real life, we would never actually create a generic coin. We have things that are coins, right? So this class right here, this coin class, exists solely for the purpose of inheritance. I mentioned what kind of class is that called? I gave a vocabulary word last time. Abstract class. Yeah, so in object-oriented programming paradigm, an abstract class would be a class that sole purpose is to act as a base class for something else. You know, we never, as we're walking through normal life, we never come upon a generic coin. We come upon quarters or they're coin versions of pesos, right? It's got to be. I was just in Mexico, but everybody uses credit cards. Okay, but whatever. You know, we have specific types of coins, but you never pick up something. Well, that's a coin. You might say that at first, but then upon further investigation, you determine it's a very specific kind of coin, right? So in the world today, there does not exist the idea of a completely generic coin. So this guy exists solely to be the base class for things that are coins, something that has an is-a relationship with coins. And typically, if we think about a coin in real life, we're thinking, okay, it's probably circular, probably made of metal-y stuff. It's not made of metal. You know, like if you go to the casino, looks kind of like a coin, but we usually call it a chip, right? Not made of metal. Second, it's made of metal, it's a coin. Something like that. But we have this concept in our heads as a human being of what a coin is. If somebody put 10 things in front of you, you could pick out the four items that are coins out of those things, right? Maybe one of them's a quarter, maybe one of them's a Canadian something or other, you know. But so there are specific types of coins, but we could say, oh, that's a coin. And then we could further differentiate that and say, oh, well, what if I say, well, pick out the US currency from this collection of coins. You could flip through and you could identify the things that you recognize as being US coins, right? And for most of us, you know, you're going to have your core things, you know, quarters, dimes, nickels, pennies. But then you got a couple of those weird ones like the half dollars and the dollar coins. Those might be a little harder to pick out because, you know, they're more like, you know, nobody uses those anymore, right? It's kind of like trying to pay with $2 bills. You know, it's technically legal tender, but most people, I mean, you'd have trouble. I mean, heck, I was at a McDonald's the other day and they couldn't make change out of like anything. So I think if you hand them a $2 bill, they might give you a 20 back. Have you ever had that happen before? You were at a place and you gave them money and then they ended up giving you more money than you gave them back as change plus your food? I mean, but like, there isn't really an excuse for that. I mean, it's one thing, like, you know, like they should be able to do that math in their head, but I mean, they have a computer in front of them. And have you ever worked at a McDonald's or a fast food? Fast food. Now all the registers just have pictures on them, right? They don't even want you to deal with numbers. Just click the Big Mac. You know, that's what's wrong with society now. We're in a downward slide. Pick the food they asked for.
This gas station that my girlfriend used to work at, they made them take math tests so that you could do the math in your head, and you couldn't use a calculator or anything. You couldn't do all the math.
Respect. But now, I mean, we're a society of convenience too. I mean, most of you, you know, you're carrying around credit cards or debit cards, and that's our preferred way of paying for things, right? Okay, and by the way, if you don't have a credit card, you should all get a credit card to start establishing credit. Don't leverage credit. Put anything you were going to pay cash for on the credit card, then pay off the bill in full each month. by the time you're done with school, you'll have an 800 credit score and you'll be able to get all sorts of, good things and stuff. Otherwise, if you don't have an established credit history, you'll be in trouble. But that's your financial 2 cents. But in any case, we're a society of convenience. We don't want to carry. How many of you carry coins? Not if we have to, right?
Yeah.
We just look for our first opportunity to get rid of it. So, in any case, we've created this hierarchy here of various representations for our coins so that we can have a collection of things that are coins, which also are US coins, which also might be a quarter. So if we come down here, I think at the very end of class, I went through and we created a bunch of random quarters, dimes, nickels, pennies. And then here, I'm gonna get rid of our code for counting stuff here, just so it's not in the way. And then I went through and I printed all those coins. Now notice here that when I print a quarter and I print a dime and I print a nickel and I print a penny, what is it actually calling here? I'm going through my collection of coins here's my empty list of coins. This is where I add stuff to my coins. So when I do for coin in coins, each time through coin will be the next coin in my collection of coins. So when I say print coin, what's it actually calling here? What function is it calling on that coin? This was gonna be on the quiz, people. Go ahead. Guess right. What function is it calling on this coin thing here? Yeah, so it's saying dot underscore str. It's calling that guy, right? Okay, that's the function the print guy calls. Now, does quarter have an underscore str? Does dime have an underscore str? Does nickel have an underscore str? Does penny have an underscore str? Yes, they do. All of them have it. Why? A quarter is a what? A dime is a US coin. A nickel is a US coin. A penny is a US coin. If we go up to US coin, does this guy have an underscore string? Right here. Does that make sense? So when we created a quarter in terms of a US coin, this is how we inherited from US coin. We got all of the things that a US coin has, including its string function. Okay? Now, just as a reminder here, so as I go through my collection of coins, remember I filled my coins up, which has kind of a random collection of quarters, dimes, nickels, pennies. I rolled a dice each time through here and either put a quarter in there, a dime, a nickel, and a penny. And this 2019 was the printing year, or the minting year. So when we went and ran this guy, we got stuff that looked like this. US currency, value 1, year 2019, value 5, year 2019, value 25, so on and so forth, right? So notice that a US coin string method returns a string that says US currency, passes the value, or prints out the value, prints out the year. Well, actually, this doesn't print anything. This returns a string that the print function then actually displays to the screen. All right, but when we try to print a quarter, it is calling quarters version of str, underscore str. And quarters version of underscore str came from his parent, which is US coin. Dimes version of underscore str came from his parent, US coin. Now, what if I did this? What if I just said for dimes? So I'll just leave quarters, nickels, and pennies alone. They all get their copy of str from their parent. But for dime, I'm going to go ahead and override the one I got from my parent. And this guy just says a dime. So there's a dime. There's a couple more dimes. So on and so forth. All right. So down here when I print these, it's always calling coin underscore underscore string. And just to prove that real quick, I'll just take that part off. And we'll see exact same output. Okay. But here's a trick question. We did cover this. I even covered it as a trick question before, so we'll see if you paid attention. Is doing this right here, printing coin and printing coin.str, is that calling the same version of print? Remember, we talked about there's multiple versions of print. There's a way that we know how to print an int. We know how to print a double. We know how to print a Boolean. Is this calling, is print coin str the same thing as print coin? Is it calling the same version of print? What does coin.str ultimately boil down to? What does that resolve to? What kind of values does our str function boil down to? Cat, dog, or string? String, good. So that guy boils down to strings. So right here, ultimately, print is printing out a string. That's what that highlighted code boils down to, is a string. Okay? Now, what is that guy? What kind of animal is a coin? Okay, that is what it'll boil down to, but what is a coin? Is a coin an int? Is a coin a double? Is a coin a Boolean? Is a coin a string? What is it? When do we use, what do we use the class keyword for? What are we creating when we use class? Objects. Objects. Okay, so this guy is an object, right? So we have a version of print that knows how to print objects. And when you pass him an object, what does he do? He calls that object's underscore underscore string, or str underscore underscore. He calls that guy's function. Now, how can he know that that object has an underscore underscore str underscore underscore function? How can he rely on that? Right now, as we have it set in our code, we wrote an underscore underscore str for, did I do it for dime? For dime. We also wrote it for US coin. Did we write it for coin? We did. There's our coin. So this guy has an underscore underscore str. This guy has an underscore underscore str. This guy has an underscore underscore str. This guy has an this guy has a direct underscore underscore str. This guy, and this guy, they received their underscore underscore str from their parent, which was US coin. Go ahead.
So basically, the dime in particular, it has its own.
Okay, so
It has its own STR method, as opposed to the other ones which get their STR value from the main.
okay, well, let's see this in action. So I'm going to go to this str thing here, and I'll just bang on the keyboard a little bit. Okay, so we've removed the str function from dime. It now has this strangely named function. All right, then we'll go up to US coin. We'll do the same thing. Now US coin doesn't have an str function. We'll go up to coin. We'll do the same thing. So now coin doesn't have an str underscore str function. Let's save this. So now none of these guys have an underscore str. This guy does not have an underscore str. This guy does not have an underscore str. So we would expect potentially our code to break now. But instead, what's going to happen? What's my output going to be? A bunch of memory addresses. Right? Because object, this guy right here, which we did not write, that came with. Did it give me an object here? Did I click? I clicked. Oh, yeah, there it is. This default object, I have it in red because we didn't write that guy, right? He came with Python. He has built into him. Oh, come on. You can do it. An underscore str that returns string rep of memory address. So a generic object comes with a string representation. It comes with a string function that returns a string representation of a memory address. Because at the very, 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 very top here, when we wrote coin, that guy actually inherits from something called object. Okay, and we'll see if I guessed right at its actual name. It's probably object in all caps, might be object in all lowercase. All right, so it's not in all caps. Let's give it the old lowercase. It could also be something weird like OBJ or something like that. Yeah, it's object all lowercase. So if we want to make our picture completely accurate, there exists a top level class called object all lowercase that comes with Python to support its object orientedness. And it already has some stuff built into it. That's why the print function here, I'm calling it down here, that's why this guy can rely on when I pass in anything that is an object. Is it true that a penny is an object? Go back to this picture. Is a quarter, is it true that a quarter is an object?
Yes.
Is it true that a dime is an object? Is it true that a nickel is an object? Is it true that a penny is an object? Is it true that a US coin is an object? Is it true that a coin is an object? Anything that we define using the class keyword is a object. Now, we are not required, we built our coin here, we don't have to use the inheritance syntax here and specify that it is an object. If I choose not to write it in there like that, by default, he will be an object. All right, so at the very, very, very top level, where we're creating our very first class in the hierarchy, so we don't have control at this level. Where I have it in red, it's out of our hands. But when we created our coin here, we didn't have to let Python know that we wanted that guy to inherit from object. Because defining a class that doesn't otherwise inherit from something automatically will inherit from object, because that is the most generic object you can have in Python. And that model works across the board in object-oriented languages. In Java, it's object with a capital O. In C#, I think it's a lowercase o. Rinse, lather, repeat. You know, every language is going to have a top level. This picture would be the identical picture in 100 different object-oriented languages. Just changing the case sensitivity of the word object slightly. Make sense? This goes all the way back to week 1, where the language doesn't matter. You know, you guys saw in the hackathon, most of you have never seen Java before. You picked up on it pretty quickly, right? Programming just like anything else, just the weird syntax. Oh, less colons, more curly braces. Move on with life. Plus, you got this weird semicolon you got to throw at the end of every line. It's little nuances like that, but not the, you know, these aren't game-changing type things. All right. So we understand that objects come with kind of a bare bones skeleton of everything that things can rely on. And this print function can trust, this guy right down here, he can trust that if I pass him an object, that object 100% will have an underscore underscore str underscore underscore function because the top level generic object comes with it. So we definitely have one. It might not be overly pretty, right? Right now we don't have a super pretty version of string. You know, it just gives us these crazy memory addresses, which, hey, it looks real technical. So it makes us feel cool, but it still exists. All right? Everybody cool with that? All right, so that is the inheritance model, and we want to understand that we get some of those base things from object. We also want to appreciate that our very top level, our first opportunity right here when we wrote coin, that's when we're saying I am inheriting from object. We don't actually have to specify that. It happens automatically. But if it makes you feel better, you certainly can write coin using the syntax of inheriting from object. No harm, no foul. Make sense? Okay. So this isn't like an exception to the rule. It's just kind of like, hey, you don't have to write that part of the syntax if you don't want to. But if you want to memorize like single syntax for every class, it's always class, name of the class, who he inherits from, in parentheses. And if it's the top level, he inherits from object all lowercase. All right, so questions about inheritance. Go ahead.
So the print coin and the print coin, you know, the str function, you basically print out the same output.
Yeah, so this guy right here, right?
Yeah.
These guys will ultimately display the same thing to the screen.
Okay.
But this guy here calls the print, let's the version of print for objects. This guy calls the version of print for strings. So there's several versions of print, one for numeric literals, one for decimal-based literals, 3.14, stuff like that, one for Boolean literals, one for strings, and then one for the catch-all. If it's an object, I'm going to call it string method, and he has one. It might not look pretty, but it'll work. Okay, so even though these guys ultimately produce the same visual output, the way it's getting to it is by calling different versions of print. This guy is an object. This guy is a string. Does that make sense? So we have to resolve those variables. And actually it's that, coin dot string like that. Okay, so with that in mind, let's go ahead and let's just dump all that. So let's go ahead and let's go back and reimagine our deathmatch, okay, in terms of objects. So we'll say Deathmatch Reimagined, remastered version of Deathmatch. All right, so, you know, at the top level, we probably have a person, right? So let's kind of build our hierarchy. So we have a person. It is persons that fight each other to the death. Now, within person, we might have a couple of subclasses. Okay, so maybe we have a mage, and maybe we have a fighter, something like that. Make sense? All right. Well, that's a race. Dark Elf isn't a class. Like, what are you? What are you talking? Well, see, he tries to act nerdy and didn't pull it off. Is what happened.
It's pretty sad. Not
Oh, I'll help you. I'll help you here. So maybe under mage, maybe we'll do something like a necromancer. Oh yeah, yeah.
all right.
Okay. So we have a necromancer, and then maybe we have a wizard type. So actually, let's call this magic user, and we'll call this guy a melee user. Okay. So we have a necromancer, and we have a wizard. I'm a ninja every single day. You ever read the Onion article of people are disappointed that they missed the annual ninja parade going through town? Children just magically found candy in their pockets, but they're ninjas. You don't see them. The ninja parade silently came through town. There's another one about Chrysler recalls their neck belt safety device. And then another one, instant win airbags, where you get in a crash, the airbag goes out, and you win gift certificates like Office Depot and stuff like that. It's like all I could think about is getting the glass out of my eyes to see if I was going to be the next big winner. And then the greatest failure was the Amish space program. They just don't understand why the all-straw shuttle burned. It was first spacecraft on its way to land on a star, burned up on as soon as they ignited fuel. All the pre-fuel tests worked great. All right, so melee user. Maybe we have a warrior, and we have you want to have a ninja, and we have a ninja. Okay, so maybe we have this kind of breakdown. Now, a person, we're going to say all persons have hit points. Okay, maybe strength, agility. Let's say that's kind of the hit points. Let's just leave it at that. I don't want to overcomplicate it for the assignment. Okay, so we're going to say persons have, actually they all have a name as well, right? So persons have name, hit points, strength, and agility. All right. Then, actually, we'll also give them an intelligence. So intelligence, these are all like numbers between 1 and 20. You can decide how you want to make it work. But these are values that may or may not be used down here depending on what your class is. We're going to say that all magic users add something called mana. This is like your magic firepower. Your how much fuel you got in the tank. Okay? And we'll say all melee users have a maybe something like an energy. What you kind of for special moves, something like that. All right. Now, necromancers. These guys, they're going to have a pet name. Because necromancers can summon zombies or whatever, skeletons to fight for them. Okay, so they're going to have a name of their pet. Okay. A wizard. Let's see, what's differentiating a wizard from a magic user? What can a wizard do? A what? Hat color? It might work. I like that. Maybe magic type, elemental type. Okay. So elemental type is like they're either a fire wizard or an ice wizard or a electricity wizard, Okay. Or chaos mage. There's old mud I used to play where you played a chaos mage and you had this special spell called a chaos bolt. It was the only thing in the game that could potentially kill like one of the admins in the game. But it either did a whole bunch of damage or it could like drop something on your head and kill you, and it was used with caution. So maybe a warrior has a maybe he has a defense, something like that, and a ninja has a maybe something called speed. Keep it simple. Okay, so for homework for Wednesday, we're not implementing the whole deathmatch thing. I want you, yet, implement the object-oriented hierarchy for this, okay? With the appropriate constructors for being able to call upon the person's constructor from within the magic user constructor, from within the necromancer constructor. Okay, so prove that you can do something similar to what we did in here with the coin to US coin to quarters, dimes, nickels. So necromancer and wizard are kind of like quarters and dimes. Warriors are kind of like pennies and nickels. Melee user and magic user, these are kind of like US coins, and person is kind of like coin. That makes sense? All right, so for Wednesday, you're going to do this. For Friday, we're going to take the assignment to the next step. But remember, there's a hackathon on Thursday from 3 to 6 p.m. in the Albrecht Lounge here on campus. If you are able to attend, make sure you go on Slack today and click that link and sign up for it. That will get you out of the assignment that's due on Friday. I still recommend you do the assignment for practice, but if you want to do time management or whatever, you don't have to do the assignment for Friday. Instead, you can attend that hackathon. But the assignment is not a penalty assignment. It'll be the normal homework assignment I would give for Friday anyways. You just get a get out of jail free card if you need it. Huh? You don't get double credit, but you will get more knowledge. Yeah, so I'd recommend that route. You should go to the hackathon anyways, but I'm throwing a little bribe in there. But it's not a penalty assignment. I'm not going to make it like this crazy impossible assignment. It's going to be the normal assignment that I would give anyways. Yeah.
At practice, it starts at 3, and it'll probably end around like 4. If I show up an hour late, it's okay.
That's fine. It's fine. Yeah, do it. I'd rather you attend it for as much as you can than not attend at all.
So register online, like on the website?
Yeah, well, yeah. So I gave you a link on there.
Yeah.
To follow that officially registers you with the Commons. I don't know if they're bringing food or that's for prizes. I don't know what they need the list for, but they want to know everybody who's coming. So make sure you follow that link today.
What's the end goal for this?
You can go to their website and read about it. It's like I think you're just doing. It's not a coding thing. It's more of like a pre-designed thing. So everything but the coding. But we went to one before with the Commons and it was fun. It's a good experience.
Do we need to do this list?